Okay, a box contains 10,000 tickets. 4,000 are zeros, 6,000 are ones, and 10,000 draws will be made at random with replacement from the box. Which of the following best describes the situation and why? The number of ones will be exactly 6,000. Definitely not. Should be close, but not exact. The number of ones is very likely to equal 6,000, but there is some small chance that it will not equal 6,000. No. So 3 says the number of ones is likely to be different from 6,000, but the difference is likely to be small compared to 10,000. Yes, that's the one we don't expect 10,000, we expect to be close. And the more draws we do, the further away we're going to be in absolute terms, but the closer we're going to be in relative terms. All right, number 3. A gambler loses 10 times running at roulette. He decides to continue playing because he is due for a win by the law of averages. A bystander advises him to quit on the grounds that his luck is cold. Who is right, or are both of them wrong? They're both wrong. Why? Okay, there's no luck, certainly. I haven't heard the... No. Oh, good. There you go. What's that called? It's not the law of averages. Independent. The spins on a roulette wheel are independent. Oh, I wonder... I'll have to look and see if I can find this. I thought it was in the book. The Monte Carlo roulette, did you... Okay. All right. 4. A die will be rolled some number of times, and you will win $1 if it shows an ace more than 20% of the time. So first off, what do we expect when we're rolling a 6-sided dice? How many ones do we expect? 1 out of 6, which is like 16.6%. Okay? So if we want to have a 1 more than 20% of the times, do we want 60 rolls or 600? 60. Because percentage-wise, we're more likely to be off with few rolls than we are with more rolls. Okay? What if it said you want to have 10 more rolls than average? Would you do 60 or 600? 600, because the absolute number is going to get bigger, the percentage is going to get smaller. Are you tired of me saying that yet? Because I'm not going to quit. Because over and over and over, we need to understand that. As in A, but you win $1 if the percentage of aces is more than 15%. What's the expected value? 16.6. So if we're higher than 50, we win. Do we want a few or a lot of rolls? A lot. As in A, but you win $1 if the percent of aces is between 15 and 20. We would want a lot, right? And D, you win $1 if the percentage of aces is exactly 16 2/3. You'd want 60. Yep. Really, you don't want 60, you want 6. Why not 2? You can't, right? You can't get 16% on a coin with 2 flips, right? So you could do 6 or 12 or 18, some multiplication of 6. I'm wondering if B is actually the other way around. I'm not sure. Yeah. I don't know. I'd have to... B's kind of tricky. Because it would say... So here's what I'm thinking. In the 600 rolls, here is our 16%. And 15% is going to be like right here. because it's wider, right? 0 and 100. But in our 60 rolls, I think 15 is going to be further away, right? So which one has more area? I think the bottom one has more area, so I think I got B backwards. Okay. Because the more rolls you get, the taller the middle of your histogram is going to be, right? Because if you roll 6 times, what's the chance that you get 0 sixes or 0 aces? Pretty high. But if you roll 600 times, what's the chance that you get 600 aces or 0 aces? Is very, very small. So I think the other graph kind of looks like this. Right? Let me do that again. So, nope, that's a bad one. So that might be 60 rolls. If I do more rolls, then it would look like this. Right? If you roll 1,000,000 times, what's the chance that you get 0? It's pretty impossible. And if we rolled more, then it would look like this. They all have the same area, but the more you roll, the closer it is to the middle. And the reason of that is the SD. Right? The more times you roll, the smaller your SD is going to be. The fewer times you roll, the larger your SD is going to be. So yeah, I'm pretty sure B is 60. All right, what's the next one? 6? According to genetic theory, there is very close to an even chance that both children in a two-child family will be of the same sex. Here are 2 possibilities. 15 couples have 2 children. In 10 or more of these families, it will turn out that both children are of the same sex. 30 couples have 2 children. In 20 or more of the families, it will turn out that both children are of the same sex. Which possibility is more likely and why? All right, so number 1. So if we study more people, our absolute error is expected to go up, but our relative error is expected to go down. So what is the absolute error in 1? How far off were they from what we expected? Not 5. We expect 15 couples, we expect 7.5 of them to have kids that are the same gender. And we had 10, so we were off by 2.5. Okay? For number 2, how many do we expect? 15, and we had 20. So for the first one, we had 15, we expect 7.5, we got 10 with the chance error of 2.5. For the next one, we have 30, we expect 15, we got 20 for a chance error of 5. What about percent error? So 2.5 divided by 15 says my chance error is 16%. And then here, 5 divided by 30, my chance error is 16%. Okay, but we expect, the more we do, we expect this number to get smaller, right? So which one is more likely to happen? The first one, because it has, that one is expected to have a larger chance error. The chance errors are the same. Let me rephrase that. But the first one is expected to have a larger error, a larger expected error. Okay? So what's the chance of being off by 16% in the first one compared to the second one? It's more likely, right? We expect this number to go down the more we play. So if the errors are the same on both of them, the first one is more likely. Okay. And you'll never know if I'm wrong. Okay, number 7. A quiz has 25 multiple choice questions. Each question has 5 possible answers, one of which is correct. A correct answer is worth 4 points, but a point is taken off for each incorrect answer. A student answers all the questions by guessing at random. The score will be like the sum of blank draws from the box blank. So, if you get it right, you get +4. If you get it wrong, you get -1. So what is in the box? So 1 +4 ticket. So there's a 4 and 4 copies of -1. Okay? So I'm going to do the same thing we've done over and over. What is the sum of the box? The sum of the box is 0. What does that mean? What does the sum of the box mean? If you answer, if you pull all 5 tickets out of the box, then you will end up with 0 points. Okay, so put that in terms of answering a multiple choice question. If you guess on 5 questions, you're expected to get 0 points. Okay, what is the average of the box? 0/5. What does that mean? Each guess has a chance of 0 points. Does that make sense? Okay, so the score will be like the sum of, if we have a 25 multiple choice question or test, is like 25 draws from the box, 4, and then 4 -1s. Okay, so if you guess on all 25 questions, how many points do you expect? 0. So if you're answering this test, if you're doing this test, and you know most of the answers, but there are some answers you don't know, is it worth guessing? No, unless statistically it's no, but practically it's yes. Then it's not going to matter, right? If you, oh good, that's what I'm saying. That's what I'm getting to. If you randomly guess, it's not going to matter, right? What if there's only one question you don't know? Then worth guess. It's worth a guess, right? Right? What if there are 2 questions? Still worth it. 3? Yes. 4? Yes. 5? Doesn't matter. Right. But you're playing the odds. Right. Okay. Now, when you take a multiple choice test, you usually don't just guess. You can usually eliminate some of the answers. So if you look and say, and the answer is supposed to be 8, and you look and one of the answers is -7, and you know there is no way the answer can be negative. And one of the answers is 110, and you know it can't be that high. Now you've eliminated some of the wrong possibilities, which essentially takes some of the negative tickets out of the box, and that increases your chance of winning, and guessing would make sense. Okay? Now, What if we changed this to a 2? Now the sum of the box is, it's no longer 0. We have 1 copy of 4 and 4 copies of -2. It's -4, right? So -4/5 is -0.8. What does that mean? Every guess is worth -0.8 points. Should you guess on this test? No. No. Now, if there's only one question and you have it down to 2 possibilities, it might be worth guessing. But if you have no idea what's going on, guessing is bad, because if you do 25 draws, so 0.8 times 25, if you guess on every question, you're expected to get -20 points. You'd be better off leaving the whole test blank and getting a 0. Depends on your teacher. Maybe you could put in -20 points. I don't know. Yeah, the previous test. Yeah, you did so bad on this one. I'm going to change your last test. um, are there tests that do that? Yeah, some math competition tests. Some AP tests work that way. When I took the AP biology test when I was a junior, I think, or senior, you did get negative points for getting questions wrong. And I believe the calculus test was the same way. So you answer the ones that you know. Yeah, it does exist. All right. 8. Do we need to do 8? A gambler will play roulette 50 times. Bad idea. Betting $1 on 4 joining numbers each time. So you can put your, if you have a square of numbers, you can put your token right in the corner, which means you're betting on all 4 numbers at the same time. Okay. If one of these 4 numbers comes up, she gets the $1 back together with the winnings of $8. If any other number comes up, she loses the $1, so the bet pays 8-1. And there are 4 chances in 38 of winning. Her net gain in 50 plays is like the sum of 50 draws from the box what? So what is in this box? 4 positive 8s and 34 negative 1s. And we're going to draw from this box 50 times. Okay, so what is the sum of the box? 4 times 8 is 32. Minus 34 is -2. What does that mean? If you play 38 times, you're expected to lose $2. So what is the average of the box? -0.052. And if we play 50 times, multiply that by 50. Oh, that should be a multiply, shouldn't it? What does that mean? You're expected to lose $2.6 every time you play 50 times. Now that's not possible, right? You could lose $2 or you could lose $3, but you can't lose 2.6. But if all of us played 50 times and we took the average of all of our winnings, it should be -2.6. Some of you will make money, some of you will lose, most of you will lose money. The average will be -2.6. And is 9 the last one? Oh, 9 and 10? Okay. A box contains red and blue marbles. There are more red marbles than blue ones. Marbles are drawn one at a time from the box at random with replacement. You win $1 if a red marble is drawn more often than a blue marble. So you have two choices. You could either draw 100 times or 200 times. Which is better? 100 or 200? Why 100? So the more we draw, the closer we are going to be to 50%. Okay, so which of these two? Okay, so let's do this. Which is which? So the red one is 200 and the green one is 100. Well, let's figure out what it is first. Okay, what's the chance that you are going to be to the right of that line? 50%. On the line or to the right. Okay, but if you're on the line, do you win? No. Why not? It says you win $1 if red shows up more often than blue. So I'm going to draw a blue interval and a black interval. Which one of those belongs to the red graph? So this is, I've made it a little wider. So this is exactly 50%. Okay? Or this is exactly 50%. Which 50% belongs to the red? The blue one. Why? It's the red graph is more smashed towards the middle, which means the columns are narrower. Right? The 50% mark is narrower. So I'm going to draw that in red. That's my 50% mark in red. Okay, in green, this is my 50% mark. So what do I want to know? What am I looking for in these two graphs? To the right of that box. Which one of those has more area to the right? The red one does. Right? So the chance of getting exactly 50 with 200 is less than the chance of getting exactly 50 with 100. If they're equal, do you win or lose? You lose, right? So all of this stuff is a lose. And the 50% column is also a lose. Right. I want the narrower one because that one has more area to the right, which is kind of counterintuitive. Should we flip coins? I might be able to put one together. So Aubrey, how are you going to explain that using chance error? So percentage-wise, the more we do, the closer we are to 50%, which means the area to the right of 50% is larger because that 50% column got narrower, right? So I don't know if you can see this. Let me. So what I've done is shaded to the right of the 50% mark, and I'll get rid of everything but those. And you'll see one is larger than the other. Why is it larger? It's larger because the middle is narrower. So you definitely want to do 200. Choose one of the four options below and explain your answer. A gives a better chance of winning. Yes. B gives a better chance of, or wait, no. No, one is no. So A is wrong. The reason A is wrong is the 100 has a thicker middle, which means the right side is smaller. B is yes, because it has a thinner middle, and the right side will be larger. A and B have the same chance, no, and can't tell that. Why do they do that? I don't know. The answer was 200. Okay. 200 draws will be made at random with replacement from the box, -3, -2, 1, 0, 1, 2, 3. If the sum of the 200 numbers drawn is 30, what is their average? So we have this box. First off, what is the sum of the box? Add all those up, what do you get? 0. So the average of the box is also 0. Okay? If we do the draws 200 times, so D equals 200, and our sum of the draws equals 30, what is our average? Divide it by 200. 30 divided by 200 is 0.15. What does that mean? On average, each draw was worth 0.15 or 15 cents. Okay. B, if the sum of the 200 draws is -20, what is their average? It would be -10 cents. Sorry, -0.1, which is -10 cents. Okay. In general, how can you figure the average of 200 draws if you are told their sum? It's the sum divided by the draws. Okay. There are two alternatives. You win $1 if the sum of the 200 numbers is between -5 and 5. You win $1 if the average of the 200 numbers is between -0.25 and +0.25. Well, let's divide that and see what it is. 5 divided by 200 is 2.5 cents, which means they're the same. All right, we're done.